How's it going, ladies and gentlemen? Mr. Johnny here again, looking at 20.9 problems. First one of the differences between voltaic cells and electrolytic cells. An electrolytic cell uses electricity to power chemical reactions. All right, that's what it does. It's a non-spontaneous reaction forced to occur. So this wouldn't happen normally all on its own. We're supplying power to it, making it happen. Definition question: what is a coulomb? It is the amount of charge passing through a given point in 1 second at 1 amp or 1 ampere. All right. So that's going to come in handy when we look at some of these problems down here. It says, how many minutes will it take to plate out 2.19 grams of chromium metal from a solution of Cr plus 3 at a current of 39.5 amps in an electrolytic cell? So first thing that we want to do is, well, we know that chromium, in order to become chromium metal, needs 3 electrons, right? So if we're talking about charge and electrons, we know that 1 coulomb is equal, I know that 1 mole of electrons has a charge of 96500 coulombs. That's the conversion, 96500 coulombs for each mole of electrons. So I know I'm going to need 3 moles of electrons for each mole of chromium. So let's do a little math though. I got 1 second giving me 39.5 coulombs. Now you may have asked, well, how come I put seconds on top? Because I know I'm going to solve for minutes, so why don't I put time on top? So I solve for time. And then I do the whole, well, I know 1 minute is 60 seconds. Seconds will cancel out. And then I'm left with minutes, which is what I'm going to try and solve for. All right, so now I got to convert coulombs. Well, I know 96500 coulombs is the equivalent to 1 mole of electrons. Well, I also know that I need, coulombs cancel out, I'm sorry. I also know that I need 3 moles of electrons for each chromium. 1 mole of chromium. So, boom, moles of electrons cancel out. Next thing I'm going to have to look at is go, all right, well, I have grams, so I got to do a conversion. I know that 1 mole of chromium is 52.0 grams. And that's just a number you look on the periodic table. Right, so chromium moles cancel out. I'm left with grams. But now I got to go, all right, well, how many grams do I have? I got 2.19 grams, and to cancel it out, it's going to have to be the top, the numerator, right? So now the only thing I'm left with is minutes. Now, if you have especially if you have a stupid calculator, I would highly recommend you do the top together, and you get 634005 as your digit. And then do your bottom number, and you get 123240. Then you do the math, and you get 5.14 minutes. So key conversion things is 1 mole of electrons is that 96500 coulombs, and then the other, the amp, is equal to 1 coulomb per second. Right? So those are important things to remember unit-wise. 4. How many grams of aluminum are produced in 60 minutes by electrolysis of AlCl3 at a current of 12 amps? So why don't we start with the current? I start with 12 coulombs per second. And I know I'm going to have to figure out minutes, right? So I'm going to cancel seconds out. I got 60 seconds in 1 minute. It cancels out my seconds, and they give me minutes. So now I can times by 60 minutes over 1 because that's what it is. So now I'm left with just how much charge has gone through. All right, so now I can go, well, let me figure that out. Charge to electrons. I know that 1 mole of electrons is the equivalent to 96500 coulombs. So coulombs cancels out. Now I know how many moles of electrons have gone through. So now my next step is to go, well, how many moles of electrons would I need? Well, I know that I'm going to need, well, Al goes from +3 to 0, so I need 3 electrons for each Al. So the electrons cancel out. I now figured out how many moles of Al I got. So now I got to convert that. I got 1 mole of Al is 27.0 grams. Moles of Al cancel out, and I'm left with grams, which is what I want. So I just plug those numbers in, and I should get 4.02 grams. If you didn't get that, then you did it wrong. If you have this set up and didn't get this number, then you plugged it into the calculator wrong. Right? Learn how to use whatever calculator it is that you got. You may have to do all the top numbers together and get, if you did that, you would get 1116400, and then do all the bottom numbers together, get 28950, and then do that part to get that answer. Either way, figure out how to use your calculator, use it correctly. Number 5. All right, so it says the number of kilowatt hours of electricity to produce 4.60 kilograms of metallic sodium from electrolysis of molten NaCl is blank when the applied EMF is this. All right, so this is a good one. So this is using a new formula. The watt equals NF of the voltage applied, right? And the N is going to be the number of moles of electrons. So to figure that out, we're going to have to do a side little step. 4.60 kilograms becomes 4,600 grams of metallic sodium, so NaS. So we got to go, well, how many moles is that? And the way we do that is we divide that by the GFM of 23.0, and we get 200 as our moles of Na solid, which is also the moles of the electrons, because Na is going from Na plus 1 to Na 0, right? So it's just 1 electron each, so we got 200 moles. So the work equals 200 times that Faraday constant of 96500 joules per mole volt, and then times by the 4.50 volts. So when we plug and chug, we're going to get joules, 8685 with 4 zeros after, joules. And now the important conversion here is 1 kilowatt hour is 3.6 times 10 to the 6 joules. So that is the important conversion that is new. Haven't used it yet. 1 kilowatt hour is 3.60 times 10 to the 6 joules. So now we multiply and divide, and we get our answer being 24.125 kilowatt hours, right? So that's how you do it. So important conversion factors, I will highlight right now. Right? I can't even see, all right. Here's the first, or really the second important conversion factor, and then this equation up here is new. First time we used it. Man, yellow is hard to see. Weird. All right. And then 6. How many seconds are required to produce 4 grams of aluminum metal from the electrolysis of molten AlCl3 with electrical current of 12 amps? So easiest way to do this is another dimensional analysis problem kind of deal. So we want 4.00 grams of aluminum. So, well, we don't work well with grams, so let's convert that. We know that it takes 27 grams to give me 1 mole of aluminum. So grams of aluminum cancels out. I now have moles of aluminum. Now I got to go, well, how many electrons do I need for each? Well, I need 3 electrons each because Al is plus 3, and I'm trying to get it to Al0. So 3 electrons for 1 mole of Al. Now I'm left with moles of electrons. Now I convert that to charge. I go, all right, well, I got 1 mole of electrons is 96500 coulombs. So now I got charge. Now I know, not equal sign, my bad. Stop here. They tell me my amperage. So I know that in 1 second I get 12 coulombs because it's 12 amps. And then, I plug and chug. The coulombs cancels out, and I'm left with seconds. Plug and chug, 3.574 seconds, aka 3.57 times 10 to the third seconds. Right? So important conversion factors. We got 96500 coulombs equals 1 mole of electrons. That's an important one. And the amps are coulombs, 1 coulomb per 1 second. Right? That's an amp. 7. What current in amps is required to plate out 1.22 grams of nickel from a solution of nickel plus 2 in 2.5 hours? Should be 2.5 hours. So amps, we're looking for coulombs per second. All right, so how are we going to end up with that? Well, we know the amount of stuff we need to get, so let's figure out how many coulombs that would take first. So we go, all right, well, we got 1.22 grams, and I'm going to have to go, all right, well, how many grams is in 1 mole, right, of nickel? And I look it up, it's 58.7 grams in 1 mole of nickel, so I'm left with moles of nickel. You go, all right, well, how many electrons is that? Well, I know it's going from plus 2 to Ni 0. So it takes 2 moles of electrons for every mole of nickel. Moles of nickel cancel out. I'm left with moles of electrons. So now how do I convert electrons to charge? Well, I know that 1 mole of electrons is 96500 coulombs, giving me my charge. Now I want coulombs per second. So I just found coulombs. So now what I'm going to do is divide by seconds. So I'm going to kind of cheat. And I get 1 over how many seconds? Well, it'll be 2.5 hours times 60 minutes times 60 seconds in every minute. And that'll leave me with my amperage, right? I'm going to end up with coulombs per second, right? That's the only units left, coulombs per second. So I plug and chug, and what is the digits that I get? 0.446. All right. So important conversion factors to remember here again. It's 1 mole of electrons is equal to 96500 coulombs. And again, amps are coulombs per second. All right. And I think that's it. That's it. See you in class. Bring questions.